These next set of examples also deal with function notation. Now again, we're going to use these same functions up top of f of x equals x plus 3, g of x equals x squared, and h of x equals x minus 5 to solve the next 4 examples. So let's take a look at example 1. Example 1 asks us to use the functions above to determine f of x minus 1. So the first thing that we're going to want to do is we're going to want to write out what we need to find. So we have f of x minus 1. And now, because it's asking for f, we're going to use our first function because it includes f of x. But wherever we see an x, we're going to leave empty brackets. So we have f of empty brackets equals empty brackets plus 3. Now we're going to replace these empty brackets with whatever it's given in our f of x function. So we have to determine f of x minus 1. So we're going to replace our empty brackets with x minus 1. So we have f of x minus 1 equals x minus 1 plus 3. And then this negative 1 and this positive 3 can be combined together, so we have f of x minus 1 equals x plus 2 as our final answer. Moving on to example 2, it asks us to use the functions above to determine f of x plus 1 plus g of x. So now we're going to need our square brackets again, and we're going to write out our function of f of x plus 1. But wherever we see an x, we're going to leave it as empty brackets. So we have empty brackets plus 3, and then we're going to close those square brackets, and we're going to add on g of x. But wherever we see an x, we're going to leave empty brackets. Now in our first equation, we have f of x, but it asks for f of x plus 1. So wherever we see the empty brackets, we're going to replace it with x plus 1. So we have square brackets, x plus 1 plus 3, and then we have to add on g of x. But g of x just wants us to replace x with x, so we're going to leave it as x squared. Now we have x plus 1 plus 3, which is x plus 4, and then we add on x squared. So we have f of x plus 1 plus g of x equals x plus 4 plus x squared. Now moving on to example 3, it asks us to use the functions above to determine g of a plus 2 minus h of 2. So again, we're going to have our square brackets of g of x, but wherever we see an x, we're going to leave empty brackets. And then we're going to subtract that by empty brackets of h of x. So empty brackets minus 5. Now in our first function, we have g of a plus 2. So wherever we see the empty brackets, we're going to want to replace it with a plus 2. So that's a plus 2 squared minus h of x, but it wants us to replace h of x with h of 2, so wherever we see the empty brackets, we're going to replace it with a 2. And now this is a plus 2 to the power of 2, so that's the same as a plus 2 times a plus 2, all minus 2 minus 5, which is negative 3. So then we're going to use our distribution laws and multiply these two functions together. And in the end, we will get a squared plus 4a plus 4, and then minus negative 3 is the same as adding 3. So then we can reduce this down to a squared plus 4a plus 4 plus 3, which is plus 7. So g of a plus 2 minus h of 2 equals a squared plus 4a plus 7. Now moving on to our final example, it asks us to use the functions above to determine g of b plus 1 minus f of negative b. So again, we're going to write our square brackets with g of x, but wherever we see an x, we're going to have closed brackets. And we're going to subtract that by f of x, but wherever we see an x, we're going to have closed brackets. So now in our first function, we have g of x, and we're going to replace these closed brackets with b plus 1. So we're going to have b plus 1 all squared minus f of x, but wherever we see an x, we're going to replace it with a negative b. So we have negative b plus 3. And then b plus 1 to the power of 2 is the same as b plus 1 times b plus 1, and then minus negative b plus 3. So using our distribution laws, we're going to multiply b plus 1 by b plus 1, and we get b squared plus 2b plus 1, and then we're going to factor in this negative into these brackets, So we're going to have negative 1 times negative b, which is positive b, and then negative 1 times positive 3, which is negative 3. So then we're left with our final answer of b squared plus 3b minus 2, because we combine this b and this 2b together, and then this 1 and this negative 3 together to get our final answer.